Here's question 7 on your review, the limiting reactant problem. Again, a limiting reactant means that one of the reactants is going to run completely out before the other one does. So there's going to be extra of one of them. So in this reaction, we've got 30 grams of this carbohydrate compound and 85 grams of oxygen. So the first thing we have to figure out is which of these is a limiting reactant. So one way you could do that is turn this into moles and this into moles and see if this is 11 times bigger than that in terms of moles. Okay, so that's one way you can do it. The other way is we can take these to a product. Okay, and it doesn't matter, we take them both to the same product. So I can take them both to CO2 or both to water. In this case, I'm going to go to CO2 because question B on this problem is going to ask us how much CO2 can we get from these two. Okay, so we'll say if that is our limiting reactant, we do 30 grams of it and go to CO2. So we say, okay, we have 30 grams of C7H16. It's 100 grams for a mole. I'm going to do this a little quicker than normal. Hopefully you know your stoichiometry by now. It's a 1 to 7 ratio. So for every 1 mole of the C7H16, there's 7 moles of carbon dioxide. And every mole of carbon dioxide is 44 grams. So if we do that, we get 92.4 grams. Make sure you know what that is. That's not grams of one of our reactants, that's grams of carbon dioxide. Again, that is how much carbon dioxide we can get if we use all 30 grams of this. That's if this is the limiting reactant and we use all 30 grams of it. If this is the reactant in excess, that's more CO2 than we can get. Do the same thing, again, if O2 is the limiting reactant, we do the same thing. We start with 85 grams. 32 grams of oxygen is a mole of oxygen. Our ratio is 11 to 7. Taking it to the same product, for every 11 O2s, there's 7 CO2s. And a mole of CO2 is 44 grams. So in this case, if oxygen is our limiting reactant, we can get 74.4 grams of CO2. So it's important for you to know that those are grams of the same thing. It's always the lesser one. So this is how many grams of CO2 we can get. That means that our limiting reactant is our 85 grams of oxygen is our limiting reactant. Our 30 grams of this is the reactant that's in excess. Question B is going to ask you, how much CO2 can you get? Well, we can't get this much. We could if we used all of this, but there's extra of that. Okay, we can't react all of this because we're going to run out of oxygen. So this is not anything for the problem. This is how much CO2 we get. So that's your answer to B. C's answer wants to know how much of these 30 grams are going to be left over. So how much is going to be used, how much will be left over. So if 20 grams were used, that means there's about 10 grams left over. So I always start with my limiting and go to this. So I'm going to start with my 85 grams of this, go to grams of this. That would tell me how much of this was used in the reaction out of the 30 grams that were available. So again, start with my 85 grams of O2, 32 grams in a mole of O2. There's 11 to 1, 11 O2s for every 1 of that, and a mole of that compound just happens to be right at 100 grams. So that tells me that I've got 24.15 grams of C7H16. That is, again, that is how much is used. Okay, that's how much was used in the reaction. If we want to know how much is left over, well, there were 30 grams available, 24 were used, so we just subtract those. So 30 minus 24.15 equals about 5.8 grams of extra. 5.8 grams of extra. Sorry, you can't see that on the video, but again, we start with our limiting, go to what the extra is, and now it tells us how much was used in the reaction. Subtract to get our excess.